Hello, geometry scholars. We are on skill 7.3, which is reflections. So this is our third and final isometric transformation. So transformation that does not change shape and size. So if you think of a mirror on the wall, that is a reflection. So there's really two ways that you can do reflections. So the first thing that you could kind of think about with reflections are the point rules. So what this says is, let's say that I'm reflecting across the x-axis. I take my x, y coordinate and I reflect it over like that. And my y coordinate changes in sign, basically. And then if we are reflecting on the y-axis, instead of changing the sign of my y coordinate, I am changing the sign of my x coordinate. And then for the harder examples, we have like the diagonal reflections. So this would be kind of an example of a reflection over y equals x. So you basically change the order of your x and y coordinates, and then the y equals to negative x. You are making the coordinates both different in sign, and you're changing the order of the x and the y coordinates. Option 2 would be to do something to the effect of drawing the line of symmetry, and maybe it's a non-axis. So draw the line of reflection. And then I kind of have like a general rule of thumb, which is what you do to one side, you essentially do to the other side. So if that's my line of reflection, and maybe I have a square or a rectangle, I'm going to put a dot on one of the points. So maybe if I'm like 3 units above, I'm just making up a number here, I'd go maybe like 3 units below, and I would have a dot right there. And I could do like other points on the rectangle as well, but I essentially created a rectangle of the same size and shape just on the other side of the blue line of reflection. So definitely make sure you write the reflection rules and the steps for thinking symmetry, because these are your 2 ways that you can perform a reflection. All right, our most basic example is taking a point like point A and reflecting it over the y-axis. So when we reflect over the y-axis, the rule is that you're going to take your x and y coordinate, and when we are reflecting over the y-axis, we are effectively changing the x coordinate. So I'm going to write my xy coordinate of point A. So that's going to be -1, 2. And my A prime is going to be 1, 2. So here's 1, 2. Here's my A prime. And if I were to kind of do this instead visually, I would kind of like highlight that y-axis, and we could see that A is 1 unit to the left and A prime is 1 unit to the right. The next tier of exercise is thinking about what happens if a graph is not provided. And with this one, I'm just going to kind of map out the transformation. So we have x comma y, and it's reflected over the y-axis. So the y-axis reflection is essentially going to be -x comma y. And then I'm going to take that point. So we don't start at the beginning, we take that intermediate point, and when we are reflecting over the x-axis, we are going to be changing the sign. This would be x comma negative y. So we're changing the sign of the y coordinate. So here's what happens. So point Q is 2 comma negative 1. So that makes Q prime, we're going to change that x coordinate. So instead of 2, we're going to have negative 2. And our new coordinate is negative 2 comma negative 1. And then Q double prime is a reflection over the x-axis. So this means that we don't change the x coordinate at all, but we're going to just change that y coordinate and make it a positive 1. All right, so something like the figure y equals 1 for our line of reflection, this is provided. So this is the y equals 1 line, and there's no nice point rule to do that with. But one thing that you do want to do is make sure you are counting above and below the axis of reflection. And what I would do is simply just plan this. So over here, I am 1, 2, 3, 4, 5, 6. So this is 6 above. And then I'd go 6 below. And you don't even have to really be a good artist to do this. So the numbers, they don't lie. So there's my first point. And on a test, I may have you like write A, B, C, and D. And maybe we'll call this point A prime. And then I'm going to go to D. So this is up 3. And then I'm going to just think symmetrically. So I'm going to go down 3 instead. And there's point D prime. And then I'm going to go, this one is up 4. So if I'm going up 4, I'm going to go 4 below. And that's going to get me to C prime. And if I were to ask you for the coordinates as well, you could just list the coordinates. And this is reflected over y equals to 1. So now we can kind of like see what the shape could be. And if you are super visual, one thing that you could do is you could kind of take advantage of that and figure out where that B prime is going to be. But if you're not, you could just count the units. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go 8 below. And we are right there. And that is called B prime. And then I'm just going to draw my picture here. And we essentially do have that shape. It even kind of makes the outline of a pretty cool looking 3D shape when you kind of put those little lines and planning lines that I put in. All right, example 4 is kind of like example 3, except it is a harder line of reflection. So when I do diagonal reflections, I think about diagonal units. So I'm going to kind of start with this one. So I went 1.5 diagonals. So I'm going to go 1.5 diagonals. in the other direction. And there's my point. And then let me get a different color to show you where I would put the next point. So I'm going to go 1, 2, 3, 4. So that's 3.5. So I'm going to go 3.5 the other way. So this is 1.5, 2.5, 3.5. And there's my new point. And I'm just going to make that red point a little bit bigger. So the diagonals do take a little bit of a visual skill, but if you do think about them diagonally, you'll be good. Now I'm going to go blue for this one. So I'm going to go 1, 2, 3, 3.5 diagonal. And I'm going to go 3.5 diagonal in other direction. So half, 1.5, 2.5, 3.5. And there we go. And then last but not least, we have the most involved one. We'll go pink on this one. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So I went 7 diagonal, and I'm going to go 7 diagonal in the other direction. So I got 1, 2, 3, 4, 5, 6, 7. And then I'm going to connect the dots. And I'll just kind of use the red. So here we go. And voila, we have a new identical shape that has been successfully reflected. One thing that you may want to do is kind of look and see if there are patterns with your coordinates for the x minus 1, and you could kind of do it that way as well. All right, so those are the examples that you will have in your notes. So this last part of a video, you do not have to take notes on, but I recommend that you watch it and take observations as I explain the experimental exercises. And you can really see the goodies that are on Delta Math to help you visualize the reflections. The first type of neat exercise that we have is called find the line of reflection experimentally. And what we do here is it says determine the line of reflection that would map the pink figure on to the dotted outline of the image under the reflection. So what your goal is you want to get this line of reflection exactly in the middle of these two figures, and you can kind of pivot it. And your goal is to get this blue shape and the dot to line up perfectly. And it's kind of an exact science here. One thing that you might find to be helpful is kind of think about what is the halfway point between your this point and this point. And if you could get it exactly halfway. So if I'm going from here down to there, I go down 4. And I went over to the right by 8. So what I could do instead is I could just kind of go halfway down. So if I went down 2 and then to the right by 4, that's like my halfway point. So my dot would be right there. So if you're not super visual, you could actually kind of even do like a rise over run divided by 2 sort of thing to get you to that exact point. And even having 1 point is going to really help you there. And I think it's a little bit easier to see on the bottom, where that halfway point is going to be, because when we're looking between here and here, we are exactly right at that 1,0. And then when that dotted line and the blue figure match up, you have successfully found the line of reflection. And it even comes complete with the animations as well. And you can even see, even in this diagonal line of reflection, how there is symmetry. So if you were to kind of do this in the art class, you'd kind of plan it like that as well. The last thing I want to show you today is called Find the Line of Reflection Methodically. So this is actually a guided question. So it says click and drag to draw lines connecting all corresponding points from the figure to its reflected image. So you're actually just going to be matching these corresponding points and creating the outline of the reflection. And then it asks you to look at the midpoints or the halfway points of the dotted lines. So the halfway point of this dotted line is right there. The halfway point of this dotted line is about right there. And the halfway point of this bottom dotted line is right on the y-axis. And it says draw a line through all those points. And that is, and it needs to go through all 3. And then it says now, write the slope of the line of reflection. So this is our good old friend, rise over run, from algebra class. So we went up 1, 2, 3, and we went over 1. So our slope is going to be 3 over 1. Or just simply 3. Actually, that's the reflection line, not the dotted line. And then the slope of the dotted line is actually going to be down 1 over 3. And then the equation of the line of reflection, they just like a y equals mx plus b type of thing. So our b is going to be at 3. So effectively, we have for our equation, y equals to 3x plus 3. And we're going to try those. And we are correct. And you actually discovered the line of reflection when you did that, and some interesting properties with its slope. So those are a few of the gizmos on Delta Math to make you really visualizing those reflections.